Welcome to Day 3 of our ITI Electrician Series. Today, we are mastering electric current. By the end of this lesson, you will know how to calculate exact current loads, wire an ammeter safely, and pass standard interview tests on the subject. So grab a pen and some paper. At its core, electric current is simply the flow of electric charge through a conductor. To visualize this, look at this generated video showing water smoothly flowing through a clear pipe. Think of your electrical wire as this pipe. In this diagram, you can see the direct comparison. On the left, water travels down the pipe. On the right, spherical particles representing electric charges, or electrons, travel through a solid copper wire. If you increase the amount of water pushing through a pipe, you will get a much heavier flow. In an electrical circuit, the exact same principle applies. A higher volume of electrons moving past a single point means stronger electric current. In equations and schematics, we need a standard shorthand. We represent electric current with the capital letter I. We measure that flow in amperes, often abbreviated with an A. If a circuit has a load of 5, you would say it has 5 amperes flowing through it, not 5 currents. Standardizing this measurement as amperes and using the universal symbol I ensures an electrician in Mumbai and an engineer in London can read the exact same schematic and build circuits safely without miscommunicating the load. When you are out in the field, you need a physical instrument to measure exactly how many amperes are flowing through a live wire. For that, we use a tool called an ammeter. There is a strict, non-negotiable rule for installing an ammeter into any circuit safely. This schematic shows a power source and load. Notice the ammeter is wired directly in series along the circuit path, so all current flows straight through it. Beginners often confuse this. Remember, a voltmeter is always wired in parallel. An ammeter has almost zero internal resistance. If you wire it in parallel across the power source like a voltmeter, you will create a dead short. Memorizing this rule, ammeter in series, voltmeter in parallel, separates a trained professional who protects expensive equipment from a novice who blows fuses and starts electrical fires. You won't always have a physical circuit built to test. Sometimes you have to mathematically predict the current using Ohm's law. This whiteboard shows our base formula. I equals V divided by R. Current equals voltage divided by resistance. For a standard household scenario, our voltage is 230 volts. The spec sheet for the equipment shows a built-in resistance of 46 ohms. Look at your scratch pad. Take 230 and divide it by 46. The math gives us an exact current of 5 amperes. Mastering this simple calculation allows you to accurately predict if your selected copper wire can handle the expected heat and load long before you ever flip the breaker switch. Now that we have covered the theory and the math, let's lock in this knowledge. I'm going to ask you 5 common interview questions. Try to answer them out loud before I reveal the solution. Question 1. What is the unit of current? It is the ampere, or A. Question 2. What is the symbol for current? It is the capital letter I. Question 3. Which instrument measures current? The ammeter. Question 4. How is an ammeter connected in a circuit? It must be connected in series. Question 5. What is the formula for current? I equals V divided by R. Being able to instantly recall these 5 data points proves you have the solid foundational knowledge required to pass any basic entry-level technical interview. Today, you successfully defined electric current, learned the strict rules for wiring an ammeter safely, and performed a practical Ohm's law calculation. In Day 4, we will tackle resistance. We will cover how resistors function, compare series versus parallel setups, and work through more advanced circuit calculations. Understanding resistance gives you the final, crucial piece of data needed to accurately calculate and manipulate complex electrical circuits. Subscribe to the channel, review your notes, and I will see you in the next lesson.